At this moment, you hold the conviction that the Andromeda galaxy lies 2.5 million light-years from Earth. You accept that the closest star is about 4 light-years distant. You see spatial distance as something tangible, quantifiable, and unchanging. But imagine if every cosmic distance you've ever calculated was flawed. What if distance isn't an inherent trait of the cosmos, but merely a deception conjured by your mind? What if, in the core truths of physics, space itself lacks any notion of distance? What I'm about to reveal will irrevocably shatter your grasp on the true nature of space. Distance appears as the most straightforward aspect of existence. You're positioned a certain span from the device displaying this. The moon sits roughly 250,000 miles away. The sun clocks in at 93 million miles. These separations seem concrete, unyielding, eternal. Distance is simply the gap between objects. It feels like the most basic idea in physics. Yet, simplicity often conceals the universe's greatest enigmas. And distance, this apparently elementary feature of space, proves to be one of science's most deeply misconstrued notions. Distance in the cosmos isn't what you've imagined. It's not foundational. It's not fixed. It's not even authentic in the manner your instincts suggest. Unraveling this will guide you through quantum theory, Einstein's relativity, holographic ideas, and the essence of space itself. Let's begin with a concept you might assume you're familiar with: the speed of light and its implications for distance. When scientists claim Andromeda is 2.5 million light-years off, they're framing what sounds like a spatial metric, but it's truly a temporal one. A light-year represents how far light journeys in a year. Thus, declaring an object 2.5 million light-years distant implies that light requires 2.5 million years to bridge that gap. Here's the catch, though. You're not gauging Andromeda's position in the present. You're assessing where it existed 2.5 million years back, when that light departed. By the instant it arrives at your observatory, Andromeda has shifted. It's been in motion for those 2.5 million years. The span you detect is to a phantom to Andromeda's ancient location, not its current one. Moreover, thanks to universal expansion, the present separation from Andromeda differs from the path the light traversed. The fabric of space stretched over those 2.5 million years of travel. So, the route light took isn't equivalent to today's interval between you and the galaxy. Every astronomical distance assessment mixes at least 3 distinct ideas: the path light covered, the separation at emission time, and the modern distance adjusted for expansion. These yield varying figures. Which is the authentic distance? None holds supremacy. Each is a legitimate gauge of separation, hinging on your inquiry and reference frame. No singular objective truth exists about a far-off galaxy's distance right now. On cosmic scales, distance is subjective to the observer and the chosen definition. It's not an immutable truth of existence. But this merely scratches the surface. Special relativity dismantles distance's constancy even more radically. In 1905, Einstein proved distance is relative, not vaguely or partially, but utterly, intrinsically, mathematically relative, tied to your velocity. Here's the pivotal insight: a rod zooming by at near light speed appears shorter than an identical one stationary. Not from material compression or external force, but due to spacetime's geometry, where moving entities span less in their travel direction than at rest. This is length contraction, a verified experimental reality. At 10% light speed, about 0.55 subtle but detectable. At 90%, it's down to 44% of rest length. At 99%, it's merely 14%. Near light speed, length near zero. For cosmic spans, it implies distance varies by frame. If you're rocketing toward Andromeda at 99% light speed, that 2.5 million light-years shrinks, not to the full amount, but divided by the Lorentz factor, yielding roughly 350,000 light-years. You and an Earth-bound observer would record wildly different gaps to the same target. Both are valid in their frames. No universal distance exists. At light speed, contraction hits zero. From a photon's viewpoint, if it possessed one, as we've clarified elsewhere, it doesn't. The span from origin to endpoint is nil. All cosmic gaps vanish for a photon. The whole visible universe shrinks to zero size in light's frame. Thus, spatial distance lacks absoluteness. It hinges on velocity on frame. Observers derive divergent measures between identical points, all equally legitimate. No independent truth defines the real separation between spatial points detached from the measure's motion. Yet, this isn't the ultimate erosion of distance. General relativity pushes deeper. There are space curves. Mass and energy distort spacetime's shape. Near heavy bodies, curvature is pronounced. So, the interval between points isn't set by rigid backdrop. It's shaped by matter and energy's layout around and between them. By a black hole, space warps so intensely that the trek from beyond the event horizon to the inner singularity stretches to infinity. Though the hole's radius seems finite externally, a falling observer senses immense internal expanse, dwarfing the outer appearance. Black holes harbor colossal hidden volumes. This underscores that distance isn't space's static attribute. It's molded by geometry, which shifts with matter-energy arrangements. Alter that setup, and every universal distance transforms. Distance isn't a stage for physics. It's a dynamic entity altering with the cosmos's physical state. Curved space also flips the shortest path notion. Straight lines yield to geodesics. Tracing the bend, geodesic length relies on curvature, tied to mass energy. Points near in flat space might extend vastly along geodesics if mass intervenes, or seem proximate via gravitational lensing curving light. Even co-location gets bizarre inside black holes from extreme warping. Points aligned spatially in one coordinate might diverge hugely in another. Coordinates labeling spacetime are flexible. Varied systems yield contrasting proximities and separations. This isn't mere math. Physics shifts with coordinates. A potent gravity field in one frame appears as vacant flatness in another. Vast distances in one become minuscule in others. Spacetime's invariant truths concern geometry and topology, not raw point separations. Now we reach the most profound revelation: how quantum entanglement and holography render spatial distance illusory. Quantum entanglement stands as physics' oddest feature. Interacting particles entangle into a unified system, one wave function, no matter subsequent separation. Probe one, and the other's traits reveal instantly, defying distance. Einstein dubbed it spooky action at a distance, striving to debunk it. He failed. Experiments affirm it endlessly. Entangled pairs across the universe stay unified. Separation doesn't sever or dilute entanglement. Distance is irrelevant. Entangled particles, billions of light years apart, are quantum, closer than touching unentangled ones. This exposes a key truth: quantum closeness differs utterly from spatial. Particles can be far in space yet linked quantumly, or adjacent spatially yet quantum independent. Spatial gaps fail to reflect quantum reality's core. In 1997, physicist John Maldacena unveiled a groundbreaking equivalence: the ADESC CFT correspondence linking gravity and curved spacetime to a non-gravitational quantum field theory on its boundary. The gravity realm has an extra dimension over the boundary's quantum setup. Yet they're identical. Every measure in one mirrors the other. They depict the same physics differently. This embodies the holographic principle precisely. Our three-dimensional spatial experience equates fully to a two-dimensional boundary theory. The depth dimension, fueling our distance sense, isn't basic, it's emergent, born from the boundary's quantum entanglement. Ponder this for distance in the 3D bulk. Distances exist. Gravity relies on them. Geometry dictates. It feels primal. But in the 2D boundary, no bulk distance persists. Boundary has its 2D spans, but bulk depth translates differently to energy scales in the boundary theory. High energy boundary events match near boundary bulk spots, low energy to far ones. Perceived spatial depth is really energy scaling. In quantum foundations, distance isn't core. It's a depiction of quantum freedom's relations across scales. This equivalence is exact, not metaphorical, rigorously proven. Space's radial holographic dimension emerges purely from quantum entanglement. Pioneers like Mark van Rijmsdonk, Brian Swingle, and others have sharpened this. Spacetime geometry, all distances, curves, stems from underlying quantum fields entanglement. Entanglement entropy gauging subsystems quantum linkage shapes the spacetime. Close spacetime zones match highly entangled quantum regions, distant ones weakly. Spatial distance equates to quantum entanglement, twin views of one reality. Van Ramsdonk's experiment. Diminish entanglement between boundary halves. The bulk spacetime fractures. Zero entanglement. Bulk halves disconnect infinitely. Re-entangle and they reunite. Distances shrink. Spacetime's connectivity, finite distances linking regions, arises from quantum entanglement. Strip it, space disintegrates, add it, space knits. Distance isn't innate to space. It's entanglement's manifestation among reality's building blocks. This fuels a thrilling advance, the ER-EPR conjecture by Maldacena and Leonard Susskind. Einstein-Rosen ER bridges are wormholes linking remote spacetime zones. Podolsky-Rosen EPR pairs are peak entangled quanta. The idea: ER equals EPR. A wormhole between black holes mirrors their entanglement. Geometric wormhole ties and quantum entanglement are identical, just different tongues. Thus, entangled particles link via quantum wormholes, spacetime bridges from entanglement. Seemingly distant particles connect geometrically via unseen bridges. Their distance is a mirage from incomplete viewing. Everyday distance, ruler or laser measured, is emergent macro scale beneath quantum rules. Entangled particles aren't fundamentally apart, they're bridged. Loop quantum gravity adds another layer. Spacetime isn't seamless small scale, it's discrete spin networks. Nodes are volume quanta, links area quanta. Distance is quantized minimal at Planck length at 1035 below. Distance evaporates, not unmeasurable but undefined. Space isn't endlessly splittable, it has atoms. Our continuous space approximates at larger scales, fundamental. A quantum web where distance stats emerge like temperature from molecular averages. Molecules lack temperature. These revelations stun. Galaxies millions of light years apart may entangle, rendering space moot quantumly. Stellar voids describe entanglement, not true voids. The cosmos isn't spatial sprawl. It's quantum-weaved distances, emergent quantum links. No instant teleport via entanglement. Causality holds no FTL signals or matter. Yet the vast, empty space view misleads. The universe is quantum foremost, spatial distances, macro illusions of entanglement architecture. Gaze at the night sky, Milky Way stars, hundreds to thousands light years off. You're viewing average quantum nets, not base separations. Andromeda's 2.5 million light years. Frame, observer, definition, dependent, emergent from non-spatial entanglement, the 93 billion light-year observable universe. Classical approximation, quantum basis states, entanglements, geometry emerges thence. Spatial distance is real like temperature, measurable, sensible, tech enabling. But not foundational like quantum states. It's emergent, approximate, observer, tied to distanceless depths. The cosmos isn't objects across vast voids. It's quantum, space, distances, geometry. How that quantum looks internally to macro beings of trillions atoms far from quantum gravity scales. You're not light years from stars. You're entangled via quantum webs we term space. Every bodily particle quantum links cosmic ones, apparent separations, macro shadows of spaceless quantum bonds. This is spatial distances, truth, not realities based, not absolute gaps, but emergent, approximate, observer-based quantum entanglement depiction. A handy myth we confuse for truth, too big for underlying quantum sight. The universe isn't immense, it's quantum. Quantum knows no distances.